So if we're looking at this year's HSC 2014, they had a question 12E, and it wasn't asking you to apply Newton's method, but it was simply saying basically why it doesn't work in this instance. So if you have a look at what they've given us, you've got a curve and they've taken x1 as your first approximation. Okay, and it's saying a second approximation, x2, which they've not shown where that is yet, is obtained by applying Newton's method once, using x1 as the first approximation. And it says, explain why x1 is a closer approximation than x2. Should be the other way around. And it does say using a diagram or otherwise. And generally, if they say use a diagram, then that's the best, clearest way of doing it, most simple way of doing it. So try and do that. I think if I can try and draw on this, if we're looking at Newton's method, can't draw on that. We might have to move that to the side. And I'll just redraw the curve here. And I'll show you what you could have drawn. So there's x1 about there. Now if you find Newton's method, which is essentially finding the tangent there and saying where it crosses the x-axis, that's x2. Okay. Now the root is up here at alpha. They name it alpha. So they're basically saying why. Why doesn't it work in this case? Well, we know why it doesn't work. The stationary point there. So the curve's decreasing on this side, but the point we've chosen is on the other side. Well, sorry, it's increasing that side, and it's decreasing here. So if you're taking your point before the stationary point and then the root, you're going to get the wrong answer. So using a diagram or otherwise just means drawing the tangent, putting in x2 because they don't show us where that is, so pop that into the diagram, and then say that because there's a stationary point between x1 and the actual root, then we're going to get the incorrect answer, and x2 is actually going to be further away from the root, which is not what we want.